Now we're going to shift to a topic that you've actually seen before, but we're going to cover here in more depth. We're going to talk about some models to help us understand functions. So as usual, you're going to see some models for functions. Unusual in that there are going to be four of them, and actually a fifth one in the next video. So we're going to have lots of different ways that we can understand functions, depending on what's helpful to us. We're going to talk about how these models interact with some of the functions. We'll have some examples. We'll also use the models to help us understand some of the definitions of terms related to functions. All right, so first of all, I feel like, especially if I'm giving you four different models, I should justify why we're using models in this specific situation. And I'm actually going to let Uncle Ted help me out here because the very first sentence of section 6.1 says, in previous mathematics courses, we have often thought of a function as, and then it talks about how we think of the function as. Now, notice that he's not saying this is what a function is. It is this is how we can think about functions. And when he's doing that, he's talking about models, right? So especially for functions, it's really important that we have some models, conceptual models to understand it, because sometimes the formal definition can be a little bit confusing. And I should say we are eventually going to give a formal definition, but two things. First of all, we're not even, I mean, we're in 6.1 now. We're not even going to get to it until section 6.4. And if we're going by Uncle Ted time, he doesn't even get to it till 6.5. So I'm actually giving it to you early. And not only that, but almost never do you see the formal definition of a function used in mathematics. And that includes professional mathematicians when we write articles for journals. So most of us, usually write it in a way that is reminiscent of at least one of the models that we're going to be talking about in this video. All right, so let's go to the first model. And this one you're almost certainly familiar with. It's called the input-output model. And so we can think of a function as a machine or a process that has inputs and outputs. And what happens is each time you put an appropriate input into the function, the machine or the process, the function returns some kind of output. And it has a consistency rule in that if you put the same input in twice to the function, you can't get different outputs. You always get the same outputs for the same inputs. Not vice versa. It's possible for you to have two different inputs that give you the same output, but you can't have two different outputs for the same input. So if I'm going to actually define a particular function, not define the concept of function, but like actually there's a particular function that I want to tell you, explain what it is, there's some important notational issues that we have to, and definition issues that we have to worry about. So first of all, what do I call the function? Well, usually we call the function the same we call anything else that's kind of an unknown or something that's changing, and that is we're going to give it a variable name. We give it some kind of name so we can refer to it later. We might ask, one of the things I have in that model is I talk about appropriate inputs. And appropriate inputs are inputs that are allowed, that the function allows you to give as inputs. So we need to ask ourselves, well, for a given function, what are the appropriate inputs for that function? And we give a name for that because that's going to be important to us. The set of inputs that you are allowed to put into a function is called the domain of the function. The domain of the function is a set of elements, each of which you can put in the function, and it has everything that you can possibly put into the function. And then there are two ways that we can describe the outputs. One is, how do you describe what kind of elements you expect as outputs, right? So this is when you're thinking about the outputs, but you don't want to think very carefully about what are the exact outputs that you get. Is it a real number? Is it a person? Is it a matrix, right? That's the sort of question we're answering with this one. And the codomain is literally any set that contains all possible outputs of the function. Right? So the idea here is you want to make sure not to leave anything out. If you have some extra stuff in there, that's fine. You just want to make sure there's nothing that's actually an output that is not in your codomain. Now, there may be some situations where you want to know exactly what the outputs are. Not just like what kind of outputs there are generally, but like maybe a list of the actual outputs that you get. And that set is going to be the range of the function. It's the set of all outputs. And again, here you have no extras. You can have extras in the codomain, That's okay. The range, you have no extras. You have precisely the elements that are outputs. So the question is now, how do you pair each input, in other words, an element of the domain, with its appropriate output? Well, there's a couple of ways we can express this function. We need some type of rule or some kind of explanation or some other way to pair the inputs with the outputs. So one of the most common ways you can do that is using a formula. So you can define a function f by f of x equals x squared. So I just want to sort of parse what's going on notationally up there. There are actually three things that are happening. First of all, you have the actual function, which is f. That's the name we give to the function. The input is x. That's the variable that represents what the input looks like when you put it into the function. And then the output for x, for that particular x, whatever that is f of x, which in this case is x squared. So what happens is you have a function f that's determining how to deal with inputs and outputs. When you give f an input x, it squares it, and then that is your output. So what is the domain of this function? Well, I don't tell you, but if a natural domain would be probably all real numbers, right? Because what are the sort of things that we square? We tend to square numbers, and we tend to deal with real numbers, although that's not the only possibility. But that's what we're going with here. If you think about the codomain, well, now you've got to think, I don't want to know exactly what the actual outputs are, but I'm concerned about, okay, my input is going to be a real number. When I square a real number, what do I usually get as an output? And there are lots of ways I can answer this question, but one possible way is I could say a set of real numbers. And all that's saying is, if you put a real number into the function, it will give you back a real number. You may not know which real number. There may be some real numbers that you can't get back, but you know you'll get back a real number for sure. Now, if you want to be more careful for the actual outputs, right, you might say, oh, yeah, I'm squaring a real number, and I can't square a real number and get a negative number, so I'm only going to get non-negative numbers. And actually, I can get all the non-negative real numbers by putting in their square roots, right? If I want to get a particular non-negative real number, I put in its square root as an input, and it will give me that number as an output. And so we write this f from r to r to indicate f is the name of the function, the first r indicates the domain, and that points at the second r, which is the codomain. So here's a different function. Slightly different. I want to do at least one without numbers to show you that functions can have domains and codomains that are all sorts of different things. So now we're defining the function w, so that's the name of the function. W of x is the output, x is the input, and x is a student. And we didn't say which student, but we'll define that in the codomain later. But what you do is you give w a student, and w gives you back the first class of the week for that student. All right, so our function is w, that's the name of it. The input is x, that's your student. The output for x is w of x, that's your first class of the week for that student x. So what is your domain? Well, it's not clear. I mean, I know the domain is going to consist of students, consist of people, right? But I'm just going to restrict the domain to just the students at GVSU because they're the ones who I'm really worried about their first class of the week for some reason, right? But again, that's not the only one I could have for that particular formula, but that's the one I'm telling you, that's the domain. Those are the only acceptable inputs for this function. Codomain. Well, let's see. The codomain is the first class of the week for the student X. They're students at GVSU. They're taking class at GVSU, right? So we could call it C, the set of classes offered at GVSU. Because if you think, okay, if I have a student at GVSU and their output is going to be their first class of the week, that class is going to be one of the classes offered at GVSU. Okay. Now the range might not be the same as the codomain, right? Because there may be some classes at GVSU where it's not the first class of the week for anybody. They're taking the class, but maybe for everybody it's their second or third class of the week or their fifth class of the week, depending on how many classes they have and depending on when it takes place. So the range, if I wanted to describe that precisely, that's a set of all classes that are the first class of the week for at least one student. All right, so let's go on to our next model. So we were thinking input-output. Now for our next model, I like to humanize this one a little bit. This is a question-answer model. In this case, the function is not a machine, but it is a person. And what the process this person goes through is you ask that person the question, and they give you answers. All right? So The rules are that person must answer at least one question, because otherwise they're not really a function. And if you ask them the same question twice, you get the same answer. So you can see some parallels between that and the input-output model. So here, the domain, your inputs, are going to be the set of questions that you're allowed to ask the person. So the questions sort of are like the inputs are for the input-output model. And your codomain, your outputs, those are going to be the set that includes all possible answers to the questions. Okay, and again, it can contain more elements than there are answers as long as it includes all the answers as well. And the range is the actual answers to all the questions. So if you list all the answers to all the questions and include that in a set, that is going to be the range. All right, so now we have another model. This one I call the ball throwing model. In this case, your function is a little bit different. So it actually not that much different. It's still a person, but this time it's like the coach of a team. And the coach has two different kinds of players on this team. They have throwers and they have catchers. So what happens is each thrower has a ball and is instructed to throw a ball to one of the catchers. And the rule is that each thrower can only throw one ball. Right? So they don't have an extra ball that they can throw to two different people. And again, you can sort of see the parallels between this and the question answer and the input output. Here are your inputs, here are your domain. That is the players that have balls to throw. So those are the throwers, right? Your codomain is the set that includes all possible players that will get thrown a ball. So those are your catchers. Now, it is possible that when people are throwing, not all the catchers get thrown a ball. That all that's required is each thrower throws a ball to somebody. And then your range, that is the actual players that are thrown a ball. Those are the people that actually catch a ball. Those are the catchers that actually get a ball thrown to them, at least one. Some of them may get more than one ball thrown at them, and they better have lots of protective equipment on. So this I think is a useful model for certain concepts. In particular, when we get to section 6.3, look for it when we study injective and surjective functions. And our fourth model, not our final model altogether, but our final model for this video is an arrow diagram model. This is a very visual model, so if you're a visual type person, this is one that will appeal to you. In this one, a function is someone who draws arrows between elements of the domain and elements of the codomain. The rule is that every element of the domain must have an arrow that's originating at it, so that's pointing at something. And no element of the domain can have two arrows coming out of it. Okay, here your domain as a set of all items that have arrows coming out of them. Your codomain, those are the set that includes all the items that are pointed at by elements in the domain. And then your range are the actual items that are pointed at. So where somebody in the domain is pointing at that item. And let me show you a visual on some of the two example functions that we were looking at before. So you have f of x equals x squared, and w of x equals the first class for the student x. So if we're looking at f, right, so you have a domain and you have codomain. And so let me see. So one of the elements of the domain is going to be 2. And when you square 2 for the output, so 2 is the input, you square it, you get 4. So 4 is the output, so 2 is going to point at 4. If you take 3, 3 is the input, you square it to get 9, which is the output, 3 points at 9. If you take 4, you square that, 6 to get 16, 4 is the input, 16 is the output, 4 points at 16. So that's how the arrow diagrams work. And in principle, you'd have an arrow for every single input. Sorry, I didn't have enough time to draw all the real numbers and their arrows. Maybe next time. All right, so now for W, you could have, and I got to make up students and what their first classes are. So forgive me if these don't actually work out in real life. But in the domain, you're going to have students, and in your codomain, you're going to have classes at GVSU, right? So for instance, my friend Jojo, maybe his first class is Calc 1. So he's taking Math 201. That's their first class, right? So Joanne's first class is Music 105. And then Joey's first class is Anthropology 204. And those are their first classes for the week. And so that's how the arrow diagram would work for those. All right, so I'm going to hold off on the fifth model until the next video, but for now you have enough where you can look at the two sets of activities. One is called exploring function models, where you take the function models and apply them to certain concepts. and introduction to functions that has a particular way of defining functions and some of the issues that we can run into on those.